Hello everybody and welcome to another Python programming tutorial series. This series is going to be dedicated to the use of PyOpenGL for 3D graphics rendering and all of that fun stuff. We are also going to be using PyGame in order to show our PyOpenGL objects here. So if you don't have PyGame already, you'll have to get that, and you also have to get PyOpenGL. I'm also assuming that you already have Python installed. If you do not, you'll need Python as well. So let me bring over a window here real quick. So the first thing you'll need, obviously, well, the very first thing you'll need is Python. If you don't have Python, you'll need to go to python.org and download Python. This tutorial will be concerning Python 3.4, though you should be able to do everything shown here in 2.7 as well. So you'll need PyOpenGL. You can either get it from the website, but if you're on Windows, then I would just go to this website instead. Get PyOpenGL. Make sure you don't accidentally download Accelerate. You have to have PyOpenGL. You can also get Accelerate if you want, but make sure you get PyOpenGL for the correct version, and make sure you match up your bit versions. If you get an error that says is not a valid Win32 application, you done screwed up. You have to get the right bit version. Next, PyGame. Again, you can download PyGame from here. You can go to downloads and actually download either the source, you get a Windows installer, all of that, but you can also download PyGame from the exact same website that I was showing you before. So you'll have to get PyGame and PyOpenGL, and then we'll go ahead and get started. If you haven't guessed, this will be what we're going to create within our basic example of PyOpenGL, but I'd also like to show you guys how we can make a simple but pretty neat 3D game with PyOpenGL and PyGame. So stay tuned for that. So anyways, let's go ahead and get started with some basic code. We're just going to do just the extreme basics, and I'll show you a more advanced example, which will be basically this right here, how to get this to show up for us. So I'm going to go ahead and close out of this, and let's go ahead and get started with the basics. So the first thing that we need with to do this is we're going to need all the PyGame imports and then the PyOpenGL imports. So to start, we're going to go ahead and do import PyGame, and then we're also going to do from pygame.locals import asterisk. Don't forget the L in locals. And then we want to, so that's the PyGame stuff we need. Now we want to import the OpenGL stuff we need. So we're going to go from OpenGL.gl import asterisk. If you're not familiar, that's basically import everything. And then we're basically going to do the exact same thing as this line. So I'm just going to go ahead and copy it, paste, and then it's just GLU. So these are your typical OpenGL functions that you might need, and these are some more advanced OpenGL functions that we're going to be using. So make sure you've got all that. And before we go any further, make sure you can save and run that. To do it quickly, you can save and run just with pressing F5, and that'll do it. As long as you get no errors here from these imports, then you're ready to go. If you got an error, you'll need to address those errors. And if you're having trouble addressing the error, figuring it out, feel free to comment below, and I'll do my best to help you out. So now, when it comes to OpenGL, generally all you have to do is you have to specify the object. Like, you kind of draw the object in a sort of abstract form, and then you call upon OpenGL to bring it to life. So what are the objects, right? Or what are the things that you have to define about something, like we're going to do a cube. So a cube has the following things. So I'm going to draw a cube. So that's a square. What makes a square a cube? You just draw another square, basically, and then you connect the corners. Okay. So each corner is a vertex, and a bunch of corners are vertices. So those basically are these, let me make this a little bigger though, like these spots here, right? So these are vertices, each one is a vertex, and they can also be referred to as nodes, right? So if you think of it in terms of networking, each little point, right, that all these links are connected to is called a node. So depending on who you're talking to, they might say those various things, but we've got that. So how many of these nodes, vertices, or how many individual vertexes do we have? We've got 1, 2, 3, 4, 5, 6, 7, 8. So we have to define all 8 of those. Then what else do we have? Well, the next major element we have are these lines, right? We've got these connections to the vertices. wow, that's really messy. But we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we've got 12 connections, right? And each of these connections are very specific connections, right? Because let me get rid of this massive mess that we had. Each of these connections is important because the connection is between this node. Let's say this vertex is 1, and this vertex is 2. This lined connection is a connection between 1 and 2. And instead, if we had a connection between, let's say, 1, 2, and this is 3, 4, 5, 6, 7, and this would be node 8, let's say, the connection between 1 and 8 would cause this like diagonal line through our cube. That's not the connection that we want. So it's really important that we understand what the actual connection is between these nodes, because that's what's going to create our actual object, is these connections. And then finally, the last thing that we have in our accordance to our object are the faces. So we have one face that's basically this here, right? If we were to color it all in, that's a face. And then we've got another face that is like this right here. Okay, that's another face. So we've got a bunch of faces as well. And so all of these things come together, but to define, let's say, this orange face here, it's what's inside these nodes and the lines that connect those nodes, that makes the face. So you have to define all of these things for OpenGL. Okay. So now that we have that understanding, let's close out of this. Actually, we'll leave this here just in case I want to revisit it for some reason. But now we know what we're getting into. So first we have to define what I was calling the vertices. Each one is a vertex, or we can call them a node or nodes. But probably the best name to call it is vertices. So the vertices, and this is going to be a list. Well, it's actually going to be a tuple of a bunch of tuples. So we've got this big old thing, and how many vertices did we say we were going to have? We said we would have 8 total. So let's just go ahead and pre-make the room for 8. So we've got 1 there, enter 2, 3, 4, 5, 6, 7, and 8. So now we've got 8 of these. And the way that we do this is it's basically we're going to envision this as like units. Okay, so we've got 1, 2, 3 units. Okay, so the location of these nodes is going to be in units. So let's say the first node we're going to make is 1, -1, and -1. Now it's important that you keep all of these in the identical order as you're going to connect them later on. So this would be node 1, and then we're going to keep going, and then actually, according to OpenGL, this is in theory kind of like node 0 sometimes, you know, just depending. And also Python, we'll call this really node 0. But anyways, so that's the first one. Then we've got 1, 1, -1. Then we're going to have -1, 1, -1. And if you're already feeling a little lost, I'd suggest that you just kind of hold on. And when we're all done and we're visualizing things, then if you're a little confused about where this would be located spatially, so if you're not like a spatial kind of thinker, this is maybe really, really confusing. So if you're having trouble, just wait, because this will be shown visually very soon, and you'll be able to change these variables a little bit, and then you'll see visually the difference it makes, and that might help you quite a bit. So anyways, -1, 1, -1. Then we've got, the next one would be -1, -1, -1. If you'll notice as well, we basically only change one thing each time. So keep that in mind as well. So when you're writing this yourself, there should really be only one major change right from node to node. Okay, so we've got -1, -1, -1. Then we would have 1, -1, 1, then 1, 1, 1. Then we're gonna have, and let me fix this negative here. I don't want that space. And then we'll have -1, -1, 1, and there we actually ended up having to change 2. And then finally -1, 1, and 1. Okay, so those are our vertices. Hopefully I did those right, but we'll find out really soon when we visualize this. So then when you have vertices, you also have to define edges. So edges, and the edges are those lines, right? So this is an edge, right? This thing right here, that's an edge. This is also an edge. So how many of these did we say we were going to have? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so we've got 12 total edges, and the way that we define an edge, or at least that we're going to, is we're going to say the edge is the connection between two different nodes. So in our case, like for example, this edge right here is the connection between node 1 and node 2. Okay, so when we come to edges here and we start defining our edges, we're just going to be defining all of the connections that each node makes, and just going into it, we should know each node makes how many connections. 3 connections, because you've got, like, say node 1, it has 1 connection going down here, 1 connection coming out here, and 1 connection out here. So we know that each node should have 3 total connections, and then we have a total, well, never mind. But anyways, we're going to have a total of 12 connections. But let's start with node 0. Node 0 will have, and actually let's go ahead and predefine 12 here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we know we need to populate all of those. So the first node that we're going to refer to is node 0, 0, and 0. Okay, and that's referring to the 0th element in this list. So what does this 0th element need to connect to in this list? So what it's going to connect to is element, the firstth element, right? So the second in the list, second, and then 3, and then element 4. Then we're going to move on to 2 here. 2 is going to also obviously have 3 connections. Okay, 2 is going to connect to 1, 3, and its only difference will be it'll be 1, 3, and then instead 7. Then we have node 6. Node 6 is going to connect to 3, 4, and 7. And then finally we have only 3 more spaces, so who haven't we connected anyone to? And that would be node 5. So we've got 5, 1, then we would have 5, 4, and then 5, 7. And now we've got, in theory, all of our edges. Again, when we visualize this, we'll see if we've made a huge mistake. So next, once we've made these initial parameters, so to speak, of what makes up of a cube, well, first of all, what are we missing? We haven't defined faces yet. We're not going to define faces in this video, just because it just adds too much. We're already kind of deep into a video. So we'll define faces later, but we've got the vertices and we've got the connections. So that's all we need right now. So now let's go ahead and write a new function, and this function is going to be define, and we'll just call this cube. So this is going to be our cube. And every time you write GL code or OpenGL code, you're going to encase it in GL begin and GL end syntax. So you'll have GL begin, and then you'll have GL end. Just like that, mind the caps. And then within these parameters, this one will be empty, but this one you'll specify a constant, and the constant is kind of notifying OpenGL, like, what kind of graphics are we putting up here. And in our case, since we just have nodes and lines, this is going to be all caps GL underscore lines. So this is just saying, hey, we're going to make some lines, basically. Cool. So then, now we specify the GL code that we want to specify. So we can, the way that we're going to do this is we're going to say for every edge in edges. So each of the edges in edges, what are these numbers in the edges? Each of these numbers is what? It's a node. It's a vertex, right? So then for edge in edges, for vertex in edge, what do we want to do? We want to do GL vertex 3FV, and then what we pass through is vertices with the element vertex, right? So the vertices vertex, and that's this number, and then that's corresponding to the numbered vertex in this list. It's drawing them, and it's going to connect them. It's just going to connect the dots. Now, If you are uncomfortable with, say, for example, this function here, GL vertex 3FV, what does that even mean? Well, if you go to Google and you type in the exact function that you're seeing, whether it's my code or in an example code, you hit it and you'll come to either this isn't actually what I wanted. Let's see if we can find here, let's see. Yeah, here's our documents. So we could click on this one. We'll go ahead and do the Windows version of it. But it says basically here what you would pass through here, and basically it just wants a vertex. That's what this function wants. And it is going to take your vertex and then do with it what you specified you were going to do with it. In our case, we're going to draw some lines. So that's what's going on. So we've done that, and we've done GLEnd, and now we want to actually make this show up. Okay, so now we'll go ahead and define main, and we're going to need to run pygame.init. That is the initialization function for PyGame. We have to always call that if we're going to be using PyGame. Then we're going to go ahead and set a constant for our display, and that's going to be 800 by 600. And then we're going to go ahead and set the display as we have to. So it would be pygame.display.set_mode. And this is where you would put the display parameters. It just so happens we've predefined them, so we'll just say display. And then you can add in, normally you would just leave it as display and be done with it. But in our case, we need to notify the display that we are going to be doing OpenGL. And so this is obviously necessary. If you're familiar with, say, matplotlib, you have to notify matplotlib before you start throwing 3D graphics at it. You know, before you start throwing a z-axis, you have to tell it, like, by the way, here, this is coming. And so it's no different here. So we'll have to, in all caps now, as this is where we specify constants for OpenGL. So we're going to first specify double buff, and then we're going to use the pipe, and then we're going to say OpenGL. Now, double buff is short for double buffer, and what it does is it basically has, you know, the buffer that you're seeing, and it's got like a buffer in the background, and this is to kind of work alongside your monitor's refresh rate. And then finally, OpenGL, we're just specifying, hey, we're going to use OpenGL. So that is how to set the display for OpenGL. And now we're going to set a little bit of some of our OpenGL functions here, basically, or set some parameters. So the first one we're going to use is GLU perspective. And this is going to be a few things. First you have the field of view. So field of view is in degrees. So let's just say we have a 45-degree field of view. Then we're going to have the aspect ratio. And the aspect ratio is basically width divided by height. So since we've already defined this as a bit of a constant, what we can do is we can say display 0 divided by display 1. And that will set what we need there. And then you specify here it's called z-near and z-far. And what they are is they're like clipping ranges, basically. So you've got the near clipping plane and the far clipping plane. And if you don't know what clipping planes are, I'll tell you now, but it's best, again, I think for most people to see it visually. But a clipping plane is basically the plane that clips away the showing of the object. So once you zoom out far enough from a given object, eventually it's going to disappear, right? You're not going to keep showing it on the screen, even though you can't possibly make it out because it's like a pixel size. So a clipping plane is used for this, so you can, as you zoom out, it'll just disappear. So for now, we're going to set them pretty wide. A lot of times you'll see people use like 0.1, so it never goes away until you've, like, in theory, passed it on the screen. And then you'll see usually a pretty large number here. We'll just put 50.0 for now. Then you've got GL translate F. And this one is just X, Y, Z parameters, and this is you kind of moving about the object, so to speak. For now, let's just put 0.0, 0.0, and then -5. So this is X, Y, Z. So -5, if we put a 0 here, we would be like full face, and so here's our cube, and we'd be like looking at the cube like this. So we wouldn't actually see the cube unless it was moving in some way. And so we wouldn't see it if we didn't zoom out. So we're going to zoom out. The other ones we'll cover in a little bit. So let's translate, and then you have another one which is GL rotate F, and then this one you've got degrees X, Y, and Z. And we'll just leave these all blank for now. We'll just put 20 in there for now. That won't really actually do anything. We'll just put 0, 0, 0, 0. So now we are going to call while true, and then we'll do a simple event loop. So we'll say for event in pygame.event.get. What do we want to do? We're going to say if event.type is a pygame.quit event. So this is simple Pygame code. If you want to know more about Pygame code, you'll have to check out the Pygame series. I'll put a link to it in the description. Also, this tutorial will probably stack on top of the original one anyways, as far as playlists are concerned, so hopefully you're kind of in tune, but I can imagine a lot of people start on this video. So anyway, typical Python code. Basically, this is just Pygame quit event is triggered, so i.e. someone clicks the X box in the window. Pygame.quit, then we're going to run Pygame.quit, which uninitializes Pygame, and then we'll just run quit, which will quit. So that's that. Now we'll just, within this while loop here, what are we going to do? We're going to run quickly a GL clear function. What this does is, just like when we do like live matplotlib graphs, you have to clear the slate, right? Or even in Pygame, because Pygame is just showing you frames, right? Between each frame, what do? We clear the frame with a fill, either fill white, whatever, or your image, and then we draw on top of it. Otherwise, you'd get like this really long, like everything would stay there, and it would be really heavy on your graphics. So we do a GL clear. Then in all caps, we do GL underscore color underscore buffer underscore bit, and then we'll do a pipe, and then we'll do GL underscore depth underscore buffer underscore bit. These are two constants here. And what we're doing is we're telling OpenGL, like, hey, this is what we want to clear specifically. So we'll clear that stuff. Then we go and we'll go ahead and call our cube function. So we do cube with a capital C, because that's what we did. And then back to that brings up the code into OpenGL. And then we're going to go ahead and use pygame.display.flip. In the past, we've always used update. For whatever reason, when I use update, it doesn't quite work here. Flip is the only one that works. I'm under the impression that the outcome is completely identical as long as there are no parameters in the parentheses, but for whatever reason, pygame.display.update does not work here. You must use flip. So anyway, flip, fine. And then since we haven't called any sort of frames per second here, we'll just use pygame.time.wait 10. That's basically 10 milliseconds. And that's it. So now we've got our main function here. So then we'll just call main. We'll press F5, save it, yes, cool, and boom. There is our lovely cube. Now, right now, it's just like some lines, right? It's like, well, shoot, we could have drawn that in Pygame and in 2D. What's so special? What is so special is that it's real 3D. And so what is the difference between pseudo 3D, 3D, and I suppose real life? We're not going to get into real life. But the idea of pseudo 3D versus real 3D is this. This allows me, if I wrote the code to accept my movements, this is a real 3D environment, as in I can move around the object and it will still show me the object. Whereas in pseudo 3D, or what is called sometimes 2.5D, you only have that one perspective. It's like taking a picture with a camera, right? That's a 2D picture, because when you take that picture, you can't look at that picture and like move the picture like this and see a different perspective. You know, you can't. It's just a 2D representation of that exact perspective, and that's no different than any other 2D. Whereas with 3D, you can move around this representation that you've created. So that's the major difference. So in here, the question is, well, why do I care? You know, why does it matter that, you know, this is in true 3D when I can't even move around it? Well, what we can do is really simple stuff. So here we've got a rotate function. We'll start it off with no rotate, but we can copy that rotate function, and then before, you know, right around here, basically, we'll modify it, right? So we'll say 1 degree here, and then we'll move X 3, and then we'll add 1 and 1 here. And now we'll run this. and now you have a rotating cube, and it's in 3D. Okay, so that is why 3D matters. Now, obviously there's a whole lot more to show you guys, and this was a rather long tutorial video, but hopefully I was able to cover a lot. I had a really hard time learning PyOpenGL because everyone's like, first of all, OpenGL is old, okay? So a lot of the stuff you look up is, you know, if it's current, it's generally written by people who are like OpenGL pros by now and just expect that you understand what OpenGL even is and how it works. But I know I didn't, and I expect that a lot of people don't know how it works. The other thing to watch out for is OpenGL is fully backwards compatible. So even old legacy OpenGL is going to work. So this can be kind of problematic, especially as you learn more and more about OpenGL, because you'll start wondering, like, why do I need this such and such function that's in this example? And you'll find out that you don't anymore, because that's part of old OpenGL. And there's also like 15 different ways to do one thing, right? So just keep that in mind. Some of the code that I might show you guys will be legacy, and it's fine, right? But just keep in mind that that's what's going to happen because of you're using something that's fully backwards compatible. But anyways, hopefully this was an easy enough example to understand. I know that whenever I was looking it up, I mean, people's examples were really obfuscated and very abstract, and we're using really intense mathematics that I was like, man, this is so confusing, because I'm trying to understand the mathematics behind this, and I'm trying to understand a new kind of topic. So it made it a huge burden. But I think this example is as easy as it gets, since we're, you know, very clearly defining vertices, edges. We're not using any fancy math to generate them for us and all of that. So anyways, that said, if you guys have any questions or comments, please feel free to leave them below. I'll do my best to help you guys out. Otherwise, as always, thanks for watching. Thanks for all the support and subscriptions. And stay tuned to the next one. We do have a few more things to show, and we'll also make a cool game out of this. So anyways, stay tuned for that. Till next time.